Mic on? Sounds like it is. Good. All right, we'll kick off, guys. There's still a lot of people out there, but we'll keep going. Thanks for coming along today. It's good to have everyone here and for you guys to support the community. My name is Greg Mulholland. I'm a systems engineer in the partner team, at VMware in Melbourne. My role is, I guess, to focus on our partners and particularly our alliances and some of the other vendors around it that are here today as well, enabling them to make sure they've got the full use and are realising the benefits of our technology and where we merge together. So today, this session is just going to talk a little bit about some vSphere 5.1 features, some performance features generally speaking, and maybe talk about some best practices and some ways to sort of do monitoring and troubleshooting and things to think about. Just as a show of hands, can I have an indication of anyone here who is already using 5.1 in production? Cool. So some of you guys will also, I guess, realise some extra things, hopefully, and some of you guys who are not using 5.1 will look at maybe some additional reasons why some of the pain points of previous versions that you might have that 5.1 might make a good upgrade for you. It's a bit hard for me to see the screen, but I'll walk around a little bit. So today, in the session we're going to do, we'll just run through a bit of the customer lay of the land, what we're seeing in the marketplace now, the opportunity for vSphere 5.1 and the performance features, particularly around that. We'll break down into some of those features, from a compute layer and certainly networking, storage, and some specific things like vMotion and some changes in vCenter. And lastly, we'll look briefly a little bit about some performance troubleshooting and some things to think about and how to monitor your environment for performance. So most of you guys, if you're like me, have been in the situation for a while, been in this game for a little while as well, and we've got to the point where in the early days we had a lot of virtualization was going on, and we went from that physical to virtual platform. And the easiest way for our businesses and the guys to learn to essentially play with this new technology was to pick what we call the low-hanging fruit, the sort of DHCP servers, web servers, anything that could be fairly easily virtualised. We didn't see a real problem for it. And that led us, a very good way down the path of where we are now, to a situation where there's many, many millions of virtual machines running around on our platform. There's over 350,000 odd customers that we've got, and we're building this ecosystem, and it's increasing every year. Which brings us, I guess, to the next frontier, something we've sort of realised recently in the last year or even before, around this notion of mission critical applications. So we've gone to the easy low-hanging fruit now, but we're now starting to see as the platform, as vSphere, as the platform evolves, that the capability we have to virtualise these applications, when we talk about tier 1 apps or mission critical apps, they might be something very specific in your business, but they might be things like mail servers, Microsoft Exchange, large database servers, SQL, Oracle, etc., and other systems like SAP. And even quite often they come from a different architecture or different hardware platform potentially that can now actually be virtualised. If we think about, I guess, the typical aspect of a virtual machine or a larger application, I guess now or even beforehand, 2 CPUs, 4 gig of memory, a certain requirement for IOPS, and we tend to look at network bandwidth or some sort of requirement for network capability for that particular application. When we put that together now, if we look at what vSphere 5 was capable of, this is going back for some of you guys as well, but it's important to note that 32 CPUs per virtual machine, or virtual CPUs per virtual machine, up to a terabyte of memory, 350,000 IOPS, and again, the network bandwidth that's available is growing and growing and growing. So now that barrier becomes a little bit less. And talking about barriers, with vSphere 5.1 we've increased the CPU count to 64 virtual CPUs per virtual machine. In my time at VMware, I've only ever seen a screenshot of a virtual machine with 64 vCPUs, and I think that was literally in our lab just because they decided to go into Task Manager and take a screenshot and show you how cool it was. So I'd be staggered, and I'd love to have a conversation with you if you actually have any applications that require that sort of CPU power, and if you have any hosts also that have that capability, I'd be really interested to have a chat to you. 1 terabyte of memory again, but now we've got storage partners, and even we're going to push the boundaries of where virtual machines stand from an IOPS perspective. So we've got a lot of vendors, as you see out there, and we've done some demonstrations, and certainly I was at VMworld, lucky enough to be at VMworld last year in San Francisco, and the place was just filled with storage partners who are doing all these demos on flash arrays and all kinds of different arrays. And you even, I've seen it before, they've got IO meter running, they're trying to flog the guts out of what they can actually produce out of a virtual machine to show how good their storage is. So this is becoming a barrier that's no longer really applicable to us in that sense. And the network component is growing and growing and growing. We're certainly adding some additional features that help us interoperate with, I guess, the top-level networking stack, the physical stack, and learning lots about load balancing and things like priority tagging and things like that as well, in bringing those features in so that we don't just have them at a physical layer, but we certainly can realise them at the virtual layer as well. Nope. Haven't turned it off, have I? Oh, still going? All right. So, from a performance perspective, now that platform has grown to that point where we can saturate or get to these hosts and virtual machines at this sort of size, we're starting to see a lot of new frontiers and a lot of areas open up for us. So some of the areas that are really interesting for us, and hopefully some of you guys, if you're not already, in the future may have the chance to get into these sorts of areas. Things like the areas of high-performance computing. Big data is kind of one of the flavours of the month, and things like Hadoop. All these sorts of things now can be virtualised to a certain degree in our platform, and it's an interesting way to start looking to, as I said, those barriers to simply just a server virtualisation model into, well, I've now got mission-critical applications I need to virtualise, but also I've got these other types of workloads now that I can use a similar platform across my data centre, which allows me to manage it in a much more easier way. Low latency and high throughput applications. Now we've got some features I'll show you as part of this session of how we bring those sorts of things to bear. Mega monster applications, so very large applications, and we're starting to see this really be important for some of the larger scale environments. So if you think about a traditional, you might have 30, 50, 100 hosts in your environment, that's fantastic. When you start to think about cloud, and certainly some of our service providers, and even if you're doing virtual desktops and things like that, we're starting to see maybe 100,000 or more virtual machines running on that platform. So the robustness of that platform has to scale not just for server virtualization as it did, I guess, in the past, but now into these other sorts of applications. So it has to be, as I said, very robust, but also trusted in the way that people are comfortable, and the risk is not there for people to put their applications on it. So as far as the core platform goes, I was going to say that my son could lay claim to drawing something like this, but someone came out with it at VCF5, this concept of the monster VM, and it was sort of around those specs of what a virtual machine has in its capability at this point in time. We've now upped that with the concept of a mega monster VM. And again, same sort of thing, but for different use cases, and hopefully some of you guys get to play with some of those cool large VMs in the future. If I think back to when I was doing virtualization, first of all, we had very limited understanding and knowledge of what was happening from a chip layer, a chip perspective. We turned on extensions and things like that, and that was it. But a lot of our vendors here, or Intel and AMD, are doing a lot of work in the processor architecture to understand how hypervisors work, NUMA systems, and all that sorts of things work, and bringing those additional features out and now part of the box that you buy essentially that's going to run the hypervisor for you. So that's getting better and better every time. And now, I can buy a desktop box at the moment with these sorts of, or some of these sorts of features in it. So it's good that they're working on that. There's a new setting in vSphere 5.1, which is something called the latency sensitive setting. So where you might have an application that requires, a specific or much lower latency than some of them, you might turn this on, and what you'll see is a bit of a CPU performance impact in that it's better to do that. So it makes a change, I guess, or a change in the hypervisor, the VM kernel, to a point where we can, I guess, bring that workload closer to the hypervisor. So introduce lower latency for CPU and things like that. The one thing I would mention with this, as it says down at the bottom there, is this is not just a turn this on for every single application you've got. There is a specific white paper that we wrote which details this specific setting. So if you've got an application that I would say is a production application that you really need, have a requirement for this, then go and have a look at that white paper and have a read through. And as it says there, I wouldn't be turning this on every single application or virtual machine just because you can, because you'll see some negative impact in doing it that way. But for those particular use cases that you might now come up against, this is now a feature. Some recommendations for CPU, particularly sizing is always one of those things we've had many questions about. Do I size? Do I oversize? Do I undersize? Application guys come to us and say, look, I need 16 gigabytes of memory in this virtual machine. You scratch your head and think, I wonder whether he actually really does. I'll give you a mate and see whether he notices the difference. But just be aware of what undersizing and oversizing potentially does. It potentially creates a problem in a performance problem, even if it is oversized. So monitoring that is actually probably a key aspect. Use things like reservations and limits if you so need to. I'm not a big one for using reservations particularly. I would say if you have a particular case that you need to, then fine. But I've seen some installations where people go through and put reservations on absolutely everything, and then wonder why performance is all over the place, or wonder why the application's not performing. So bear in mind that they are there for a purpose, and you should use them for that purpose, and not overuse them. Same with affinity goes, I guess. If you have a need for it, a specific need for it, that's fantastic. If you don't, leave it alone. In my estimation, provisioning is fine. In fact, in the early days and still now, it was one of the reasons why a lot of customers jumped on our hypervisor, because the ability to do over provisioning and things like that was something they could realise more a monetary benefit out of what they were doing. Hyper setting is good. Don't disable it. BIOS settings and things like that. And quite often, as you'll probably know, in BIOS settings inside a host or a server, there'll be power management settings and things like that which cause CPUs to slow down and all those sorts of things. So if you're going to do that, make sure that you have the correct usage and BIOS settings and configurations that are done. And I guess the last thing is the ESX scheduler. So ESX scheduler again is improved in 5.1. It's improved sort of every step along the way. There's a specific white paper as well about the CPU scheduler in vSphere 5.1, and it's something that if you really have either want to know, have a really good understanding of it, or have specific problems related to that, maybe go and have a look at that white paper as well. I have got a link, a slide at the end with a few links on it, which might actually help you in the end. So there's a new feature called memory overhead, or it's a memory overhead reduction technique that we have now. So what happened, I guess, we used to have this with large virtual machines as management processes in the hypervisor that has those management processes have an overhead to them that sucks memory essentially away from the host. With this feature, and I think this actually will build out for those people who are watching. So we see that we've got a number of virtual machines running on this host, and we'll have a memory overhead, I guess, for those resources or management resources there. What we have now is this setting to be able to create or allow that memory to be swapped out. So we can create here, we can create with a command line or so, we can create a swap space, particularly on the host, which then allows us to swap that memory space out to disk. And what that allows us to do is get better, I guess essentially reduce the memory overhead on each host by up to, a gig or so. So, memory, as the thing is showing here, is swapped out to the file system, and just here in the vSphere web client, vCenter 5.1, this is where we can actually go and configure the behaviour on that. An important distinction to make when you're looking at memory and memory techniques inside of vSphere, and if any of you have done any work with vCenter Ops, you'll be aware that we look at, I guess, the difference between the amount of physical memory that a virtual machine is taking at that point in time, or the amount of active memory, which is the resource demand at that particular time. So there might be a bunch of memory that is still trapped to a point, but not being actually drawn on from the virtual machine's perspective at that particular time. And that's what we call demand-based memory. So in vCenter Ops, we tend to look at demand more than physical, or consumed, I guess, because it's a much better representation of what's actually happening to that virtual machine or that host at that particular time. There might be a number of reasons why consumed memory is a falsehood, I guess, if that's the right word. So just be aware that it's important to look at that as well. From the memory perspective, we mentioned overcommit as well. Overcommit's something that most of us are sort of used to. I quite often get asked, though, what about all these different memory techniques that you have inside of vSphere? I'm going to go and turn off all these ones. I don't know what they are. I'm scared of them, etc., etc. I'm going to turn them off. My recommendation is, for most of them, as it says there, ballooning, particularly everyone says I'm going to turn off ballooning. All these things have been developed for a number of versions, a number of times, and they work extremely well together. In fact, in some ways, they're actually complementary. So turning them off may have a significant impact versus leaving them on, particularly things like transparent page sharing and ballooning and things have a very small consequence as far as leaving them on. I would say my personal opinion is if it ain't broke, don't fix it. So I always like to stay with the defaults. It's all the testing we do, and this is why the recommendation, why the product comes out exactly as it does. When you're sizing your virtual machines, try and fit them into NUMA nodes and things like that to make sure you're not introducing excess latency and things like that when you're accessing across NUMA nodes. So understanding the CPU architecture and that sort of stuff inside the box is quite key. Look at the guest OS application requirements. Every vendor that brings out, or every application vendor brings out an application says, look, we need X amount of CPU and X amount of memory. Their guidelines, that's fantastic. Again, from my perspective, it's a bit of a monitoring thing to see how that plays out. Sometimes it might be less or more depending on your environment, but it's something to keep a keen eye on. Use memory reservations. Again, we spoke about if there is a specific need and a requirement to do so that's not going to impact the rest of the environment, then fine, go ahead. That's exactly what they're there for. And do some capacity planning and things like that. Storage. So with storage I/O control enhancements, we now have the ability for storage I/O control to look, instead of setting a particular 30 millisecond contention point, which is a latency contention point, we understand that every different storage array or architecture underneath has a particular contention point. So you might be using a VMAX or an NS something over here, or HP system or 3-pass system or whatever. Depending on how they are, they're all going to have a different contention point. So in some circumstances, 30 milliseconds might be borderline acceptable as far as a latency point, but you might actually be expecting 5 to 10 based on the type of arrays that you've got and the type of workload you're running on it. So with storage I/O control, we can now take, we now have a dynamic threshold that we can set. And we have we do some testing to determine where that threshold is. We pump, information through to throughput goes, keeps going and going and going until the point that latency starts to drop, and then we start to realise that there is the contention point. And somewhere within, 10% of that is where we start to look at thresholds and things like that. The additional feature to it as well is previously before 5. As the graphic shows, previously before 5.1, we were only really looking at the device latency. So what are we reporting from the device? We now have the ability now to look right up to the kernel level as well. So the latency level of statistics they're actually gathering is much more, I guess, intelligent and well-rounded for that space. With storage DRS, we now have support for link clones and for vCloud director environments and things like that. So we're using a lot of storage profiles and things like that. When Mike talked about storage, carve-outs and things like that for vCloud director, orgs and things, storage profiles is something that we can leverage in that as well. There's also something called the data store correlation detector. Essentially, this is an algorithm when you've got a data store cluster that has a number of different data stores, and again, it was spoken about earlier, when all of those data stores might share a particular set of spindles. What storage DRS will actually do at that particular time is look at when it's doing a storage vMotion of a VMDK file, for instance, it'll go and do its checks. It'll send I/O down to each of the data stores in those particular. So there's an I/O injector essentially, sends I/O down to all of those data stores in the cluster, and it gets the reading back and says, look, the latency is the same on this data store and the latency is the same on this data store, but over here these ones are different. So it makes a determination that the response from those data stores means that they are, because the latency is exactly the same, that they are on the same set of spindles. So then when it does its calculation of where are my target data stores that I can storage vMotion these VMDKs to, it won't be those data stores that have exactly the same latency as the one that it's currently on. It'll be the other ones. So it's a more intelligent way of actually not moving something to not fix a problem, but moving something to actually fix the problem, if that makes sense. One of the main questions is always, of course, can I use storage DRS with an auto-tiering storage array? The answer is absolutely yes. All our storage partners have white papers and things like that we work with them to create best practices for in inverted commas, for these particular solutions. The additional thing there is that storage DRS doesn't need to necessarily be based on I/O or performance tiering, performance movement. So one of the really good ways or really good uses of storage DRS we're seeing is with initial placement. So now instead of me creating a virtual machine and saying, I need to create this virtual machine, I've got to choose from 20 different data stores inside, in my environment, I now look at a data store cluster and I provision into that data store cluster. So I'm looking at one object instead of 20 objects, and the data store cluster knows exactly what the space allocation is for each of those data stores, what the performance is for each of those data stores, and it can determine, so it does all the work for me. So from a management perspective, from a provisioning perspective, it's great. And also from a space utilisation, in that when I get to a threshold where 80% might be, hey, data store's filling up, we need to either close it down or don't run into a problem, that's what storage DRS is doing. It's moving. We had DRS initially and people looked at it and went, look, I'm not 100% sure that I'd turn it on in production. Now a lot of those customers that we've spoken to are just like, yeah, we just use it. vMotion is just one of those things, right? This is kind of the same sort of thing. Once people, I guess, look into it and start doing some things, the mechanism behind it is essentially storage vMotion. So there's no real huge problem with that. 16 gig fibre channel support, so obviously lower CPU usage and things like that when we've got 16 gig to the fabric. Hardware, the jumbo frame support for hardware there, SCSI, adapters and things like that, so with NFS and certainly the Ethernet networks that we use for storage in the back end growing and growing and growing. This was a good play because we've done software SCSI jumbo frames and things like that, so we're seeing a much more improved for those customers already that have hardware-based things. Some recommendations, I guess, looking at understanding your storage architecture as well is really important for what you're trying to achieve and what you've actually built. We mentioned the latency sort of thing to understand what you're designing for and what you're actually seeing. Be aware that if you're planning to use a lot of virtual machine snapshots, there is an I/O penalty, for the want of a better term, I guess, but it's not a penalty as such. It's just that the mechanism requires additional I/O at that particular time, so just be aware of that. Utilise the features like storage I/O control and storage DRS. And I say that because when you've got a number of data stores in a very large environment, as your environment grows and grows and grows, the more time you're spending manually mapping this out and managing this and doing all that sort of stuff, it's time wasted. And this, can do it quite easily. So it's a better way of actually doing it. If you have a storage array that supports and sort of software within the storage array that supports VAI and storage awareness APIs and things like that, use it. You'll see some tremendous benefits with things like copy offloads and all those sorts of things with VAI. And I would make sure, again, that if storage firmware and any software that's running on your arrays is up to date. Remember the oldies, use the right adapters if you possibly can. Don't, split them up to get the best benefit out of what you're doing if you've got some large things. And the last one's pretty important. I've worked with some vendors in the past that have specific requirements around alignment, multipathing, etc. So make sure when you're going into doing a VMware solution, and most of you guys probably hopefully are across other areas of the infrastructure, or other areas of the data center, that you're working with the right vendors and the right people to determine that, the right things for alignment and multipathing and those sorts of things are being achieved. Because otherwise you'll see, and I've seen, some results that are not ideal, and then you're left with a big screaming pile of VMware environment that needs a whole sort of bunch of change just to do that. On the networking side of it, we've got something called single root I/O virtualization, which is essentially allows a physical adapter essentially to be delivered to virtual machines as a number of logical adapters. Is the easiest way to do it. There's some significant CPU savings and things like that to be able to do that. It's kind of the direct path sort of thing. So splitting them up and giving it much faster and better access to logical devices, logical adapters. VXLAN is something that's not new for us. In fact, Cisco, VMware, Arista, and a few others also have been working on this as an IETF or a draft. And essentially what we're doing with it is, Mike mentioned, we were talking before, particularly in cloud deployments and having clusters and silos and all that sort of stuff inside our data center. And if you imagine a vSphere client where you've got a cluster here and a cluster there and a distributed switch here and a distributed switch there, excuse me, the problem often becomes that the VM gets deployed to wherever that network sits. And it can't move outside that cluster, and it can't move its way around the data center should we have particular problems or just need to scale or need mobility in that application. What VXLAN does is seek to put, I guess, a layer 2 fabric across the top of the layer, 2 layer 3 segments to a point where we can move or bridge those two, distributed switches or something like that, for instance. One of the limitations, I guess, also that we come across, particularly in a lot of cloud solutions, is even if you've got a couple of thousand virtual machines and they've got 2 specific VLANs each, then you start running into VLAN limitations with 4096, of course. And typically the virtual machine is tied very rigidly to a particular part of the network infrastructure, and it doesn't allow it to move. So VXLAN removes the 4000 VLAN barrier in 16 million segments sort of thing. And it allows us to do a lot of that, I guess, mobility and not have to be tied very, very specifically to particular areas of our switching, be it a virtual environment or particularly in a network environment. We've done some testing to get, some performance stats and things like that out of VXLAN, and the performance is fantastic. We've seen, there is a white paper specifically if you do a Google, and it's on our website. It's actually on our performance blog on specifics on the VXLAN performance tests we did, which I encourage you to go and have a look at if you want to have a read. Some I guess best practices. Again, there's that word. Converged networks is they're a great thing. But bear in mind that there's a lot of planning that goes into them. Quite often storage is the thing that saturates the converged network if not done properly. So make sure you're doing that. I would always say to everyone, now use the distributed switch. You've probably realised and you've probably seen that in the standard switch there hasn't been a lot of technology that's been brought into it over the past few years, and there's been significant improvements in distributed switch in the previous version and certainly in this version. And you'll have some wonderful capabilities in there. Mike, we tended to have this problem where we had a standard switch for management. A lot of customers would use a standard switch for management and a distributed switch for other things like storage and virtual machine traffic and things. And the reason they often did that was because they thought the same old problem, if I lose vCenter, then my management plane for the distributed switch is down and I can't access the hosts on the management network, all this sort of stuff. And Mike mentioned it before in his talk this morning that has all sort of gone. There's a recovery model for the distributed switch and things like that if you do happen to make a change or someone's changed the VLAN or something like that causes that. Utilise all the latest features and things like that, 10 gig, jumbo frames, things like tagging and priority controls, network I/O control for guaranteeing certain types of traffic, priority when there's contention and things like that. Multiple NIC vMotion and things like that. So if you've got large environments that have a lot of virtual machines and you want to do vMotion very fast, or you want to enter maintenance mode very fast, these sorts of things are important. And when you're doing your monitoring, obviously packet loss, network latency, and those sorts of things are something that need to be taken into consideration. And with the distributed switch, with things like net flow and port monitoring, those capabilities, you now have visibility into what's going on a little bit more there. vMotion, the newest enhancement to vMotion is that we now don't require shared storage to be able to do storage vMotion and vMotion. So vMotion now can do a copy across the network, essentially, of the memory state of the virtual machine, and the same thing we can do a storage vMotion. I've seen some performance, again on our performance blog, the performance of the storage vMotion and things like that, because of this mechanism and the way it's actually written across the network, is absolutely comparable to what we're seeing with storage vMotion and things like that. So it's something now that you don't need to worry about, that sort of swing data store, swing LUN we were talking about as well now. Those sorts of things are starting to become things done it again on me. Sorry about that. There we go. Parallel storage vMotion. So we used to have, you'd kick off a bunch of storage vMotions and they'd all sort of do some pre-staging and stuff, and one would complete, and then the next one you'd start to see it'd go through and complete. Sat there taking a long time. So now we can do up to 4 at any particular time. So if a virtual machine's got 4 VMDKs, for instance, we can do the whole VMDK or whole virtual machine all at once, as long as the source and destination data stores are different for them. So you can't do all 4 virtual machines essentially to the same data store. That needs to be slightly separate. And the reason for that is, I guess, because you'll start to see some performance degradation on the destination when you start to do those sorts of things. Is this working again? It is. Got a mind of its own. vMotion best practices. Block size. It's the old question, which has now kind of gone away. In VMFS5, it's all standard block size. Use multiple NICs, different subnets. Obviously, use different uplinks as well, different VM NICs. You're not going to get double performance if you're only using the same network adapter. There is if anyone wants to know specifically how the vMotion thing works and how multiple NIC vMotions and those sorts of architectures look, go to frankdenneman.nl, one of our tech marketing architects, who's responsible for storage I/O control, storage vMotion, storage DRS, vMotion, DRS, and those sorts of technologies. And he's got a number of articles going through a number of design scenarios, best practices, very, very in-depth. So I'd recommend, too much to talk about sort of thing. And even the vMotion, the enhanced vMotion capability as well, how it actually works, all the different scenarios you could probably think of. So it's the best site to go to if you just thought I'd throw that in there for him. What else we got? So vCenter, we did a major change in vCenter. vCenter now has essentially a web client, but we'll go into that a little bit later. The main change was around single sign-on. So we now have the capability, anyone using link mode to join multiple vCenters together? Yeah. So typically there was two reasons, I guess, that we used to do that. We would do that because we needed visibility of, of both vCenters or both environments, or we needed to share roles and groups and permissions and things like that. So where we've got this need for simply just seeing multiple vCenters in one client, the single sign-on capability does it for us. If we need to share roles and permissions, we still use link mode. But if we just want visibility, then vCenter 5.1 does it for us. So we can do up to 300 concurrent connections. We use single sign-on for things like vCenter Orchestrator and a number of different things as well, so that we don't have to essentially authenticate to each individual vCenter or vCenter server, orchestrator component, or whatever component we're trying to connect to. We have a single sign-on component that does it. With some statistics, we now have the capability to do things like 80 million statistics per hour at the most advanced logging level. So scale vCenter-wise is much, much better. We did some improvements. We started to split out, and we started in 5.0 in fact, but we started to split out some of the components of vCenter. We found that the more plugins, the more components, everything that comes into it starts to make vCenter a bit more of a bloated bear, I guess, that becomes a problem for our large customers, particularly because they're, vCenter is the hub of where they do all their work and where they do all their management. If that becomes a badly performing problem, then we need to do something about it. So we've started to split things like the inventory service and things like that. I'm doing a session after lunch, I think, actually on upgrading to vSphere 5.1, and I go through all the different components and particularly when and where to install them. But splitting them out as opposed to one big service that kind of runs and fails. If it fails, it fails. If it runs, it runs. Is a much, I guess, more scalable way of doing it. There's different sizes depending on which sort of size environment you want to install. I would say pay special attention, particularly when you're doing your database sizing. So get the database sizing white paper out. Understand the sort of scale that you're designing for and things like that, because getting the database part wrong quite often can cause the same sorts of problems as vCenter being a problem. So we need to make sure that the database is paid special attention to. I'm sure most of you have probably had the conversation at one point in time about a vCenter on a virtual machine or on a physical virtual machine, a physical server. I won't go into it, but needless to say, my preference is always, and it hasn't changed, has been on a virtual machine. Think about how many hosts per cluster and things like that. Although we still typically see around the 12 sort of things, maybe up to somewhere between 16, 20 or so, depending on what sort of what you're dealing with. If you want to have a more in-depth discussion with that, go and see Mike Webster as well with his VCDX session, because they'll probably go into the whole, when would I use small, when would I use, when would I use a lot of hosts and things like that. There's a lot of specific discussions to have around that. Resource pools are there. Resource pools are a much better way, in my opinion, to manage those sorts of resource and reservations and things rather than at an individual virtual machine level. They're there for needed. Don't overuse them, and make sure you understand what you're doing by setting specific resource pools. And keep an eye on, as I said, database performance and things like that. The uptime of your network and redundancy at that sort of level as well, to make sure you can actually have connectivity to wherever it is you're trying to connect to, particularly vCenter. Quickly on the performance and monitoring things, so we tend to sort of, a problem that manifests itself to us at some particular level, generally as VI admins or those sorts of people. It'll be around the ESX layer. But it's important to realise that troubleshooting that actually goes, obviously right through the stack. So quite often you'll go outside of the vCenter logs or the vCenter graphs and things like that. You might go down into the ESX, top logs or Windows and things like that as well. Quite often I've had to go down into Windows or for instance into Task Manager, into perfmon, into those sorts of tools as well. to dig out what's happening at an application level. You might need to get your application developer who wrote the code to go through and rewrite bits of it. There's things like that. Likewise, to go down to the physical layer to understand what's happening in the physical network or the storage fabric layer, all those sorts of things. So just ensure that there's no one tool that does that, I guess, obviously. So you need to understand that you've got the right people. You need to know where to actually start and where to go through. So sometimes, you get a problem that appears to be solved or to be occurring at one particular layer, and as you dig further down into it with the right set of tools, you might find that it quite often occurs or is a symptom of something happening at a different layer. If you're looking for a tool, however, that's a VMware tool that has broader capability than just looking inside log files and things like that, vCenter Operations is perfect. vCenter Operations kind of looks at, it gives, I guess, the admin a dashboard view of what's happening at any point in time in their environment. So it looks at, on the left-hand side, as you can see, the whole health column here, we look at health, and health is a snapshot of, if I've clicked on a cluster or the vCenter here.
Hello, you have been conducting a meeting for a long period of time. If you need to continue meeting, press 1 now. If not, I'll end the meeting.
At that particular time. What does the workload sort of look like? Do I have any immediate problems that are ringing bells at me that I need to go and we can do different alerts and things. But you can go through there and click through there and troubleshoot down to where exactly the problem lies, and it will give you some hints. Again, like I said, there's no one tool that does everything, but from a virtualization perspective, an ESX layer, from what we see, this is perfect. Moving to the right-hand side, we've got risk. So risk looks at not specifically what's here and now, but what's maybe coming down the future. Things like how much capacity I've got in my data stores before I start running out. How many VMs could I potentially provision at this size before I start getting to the point where I need to buy more hardware? So it's longer-term sort of risk, right? It's also looking. The heat map is looking just down on the bottom here. Is looking at the sort of issues that I might have, or that I have been having over a period of time. So it will identify, through a number of weeks, all the particular problems that might be occurring, which sometimes are really hard to see when you're only looking at a day's worth of logs or a couple of hours worth of logs because you're not seeing trends. And finally, the efficiency thing is back to where we started talking about virtualization at the very first slide. When the business comes back to it and says, look, we bought all this stuff, we virtualized everything, it's running great, we think it's running great, but go and do an assessment for me. And a lot of our partners and VMware themselves are doing a lot of work on an assessment capability to go in and say, look, you guys have got hundreds of virtual machines, let's go through and use this tool and do an assessment capability to determine whether it's being used perfectly, or have you got oversized machines? Have you got undersized machines? Have you got spare capacity that's not being utilised in your hosts? Things like that. How much can we actually pull some of this back and make it a little bit more efficient, so that you're actually drawing more money out of the environment or the investment that you've got. So in finishing, some links, and I believe these slides will be made available to you guys who have registered, or anyone, but the people who have registered, and I think also the guys on the WebEx are probably copying and pasting stuff as well. But I just wanted to draw your attention to them because most of what I've gone through today is gone through a little bit in obviously more detail and more time in the What's vSphere Perform paper, which is on our website. Again, it goes through all of those sorts of features in more detail and things like that. There is a performance best practices for vSphere, which is actually a few pages long. So if you've got a specific area that you're looking to maximise performance, it might be memory, it might be CPU, it might be storage, or whatever it is that you might be looking for, go and have a look at that particular white paper because it's really handy and it'll give you a lot of information on a little bit about what I've talked about today. The monitoring and performance thing is actually interesting as well. If you are in a position where you're hands-on doing a lot of operational sort of performance monitoring and even troubleshooting and things, that's a really good, interesting place to go. And for just general reading, when I say general reading, the VMware Performance Team blog is a really, really good spot to go. So the VXLAN performance thing, when we were talking about 1 million IOPS for a virtual machine before, the test configuration, the config guide that they did for that, plus a video of all that is all on this blog. So they come out every so often with a blog that explains the inner workings of the latency sensitive setting. How VXLAN performance tests are all done, all this sort of stuff. So again, more information on all our performance stuff. So if you're heavily performance orientated or minded, this would be something worth kind of just checking past on your daily or weekly sort of run when you're browsing around the internet at work or at home. So thanks. Yeah.